interior angles of a hexagon? 720. All right, we've got a heptagon, 7 sides. Pick one vertex, draw all of the diagonals possible from that one vertex. I get 5. 5 times 180, well, that's 900. And my last one, octagon. Pick one vertex, draw all the diagonals possible from that one vertex. Count the number of triangles. I've got 6 triangles. 6 times 180 is 1,080. So now let's see if we can't find a pattern. Well, looking at the number of sides and then going to the number of triangles. So if I have 4 sides, I get 2 triangles. If I have 5 sides, 3 triangles. 6 sides, 4 triangles. 7 sides, 5 triangles. 8 sides, 6 triangles. So it looks like the way that I have my number of sides compared to the number of triangles, I always have 2 more sides than triangles, or that if I know that I have 28 sides, I'm going to have 28 minus 2 triangles. Well, the formula for the sum of the interior angles of an n-gon is n minus 2 times 180. So this is the number of sides minus 2 times 180. So if I have a 12-gon, I'm going to take 12 minus 2 times 180. 12 minus 2 is 10. And 10 times 180 is 1,800. And so the sum of the interior angles of a 12-gon or a dodecagon is 1,800. Find the sum of the measures of the angles of a 15-gon. Okay, so we're going to take n minus 2 times 180. N is 15. Take 15 minus 2 times 180. So that's 13 times 180. And if we take 13 times 180, I get 0, 4, so I've got 540. 2,340. And so the sum of the angles of a 15-gon, the sum of the interior angles of a 15-gon is 2,340. And if I want to put a label on that, I can say 2,340 degrees. Find the measure of angle y in pentagon TVYMR. Well, since these are 90 degrees, I have 90, 90, and 90. And then I also have 135 degrees. So I can figure out how many I have total. 90 times 3 is 270, plus 135. So far I have 405 degrees. Well, from what I know about polygons and pentagons in this case, I have 5 sides, so I'm going to take 5 minus 2 times 180, or 3 times 180, and I'm going to get 540. Now if I didn't want to do that, I could go back a couple slides or go back to my notes and look and say, okay, pentagon 540, it's always going to be 540. Well, since I have 405 degrees and I need 540 degrees, take 405 away from 540 and you get 135 degrees. So the measure of angle y is 135 degrees. Equilateral polygon. Equilateral means that all sides are congruent. That would look like that. You might have a quadrilateral with all 4 sides congruent. Equilateral, all sides congruent. Equiangular, all angles are congruent. Equiangular, all angles. Regular is both equilateral and equiangular, which means all the angles are the same and all of the sides are the same. So a regular polygon, both equilateral and equiangular. Equilateral, all sides congruent. Equiangular, all angles congruent. Regular, all angles and all sides are congruent. All right, the sum of the measures of the exterior angles of a polygon, one at each vertex, is 360 degrees. Okay, an exterior angle is formed when you take one side and extend it out. So pick one side, extend it out, and then you find the angle formed by that extension and the adjacent side. Well, this is saying that if we take all of these angles and add them together, so A, B, they're not necessarily congruent, C, D, and E, and we add them all together, we end up with 360 degrees. And this is saying that it's true for any shape, any kind of polygon you have. The sum of the measures of an exterior angle of a polygon. Doesn't say pentagon, doesn't say hexagon, it just says polygon. So this would be true for a triangle, it would be true for a trapezoid, it would be true for a parallelogram, so any of your quadrilaterals. It would be true for a dodecagon. If you take a polygon, find one exterior angle at each vertex, and add them together, it's going to be 360 degrees. Well, the reason that works, the sum of the interior is n minus 2 times 180. And the sum of each of these are 180. So I have 180, 180, 180, 180, 180. So if I add those together, I have n minus 2 times 180. And since these are 180 times n, what I want to do is if I go ahead, if I add up all these sides, so 180 times n, and then I get rid of the interior, subtract off the n minus 2 times 180, then it's going to leave me with just the parts that I want. So I take 180 times n, and I subtract off the interior angle, so I get rid of this part. It will leave me with angle A, B, C, D, and E. Well, this is 180n minus 180n plus 360. So when I distribute that negative and the 180, I end up with 180n minus 180n. It's gone. I end up with 360. And that works for no matter how many sides we have. So, whatever the shape, the sum of the exterior angles of a polygon, any polygon, one at each vertex. So I can't say, oh, I'm going to do two exterior angles. One exterior angle at each vertex, 360 degrees. Okay. The board game to the right is packaged in a rectangular box outlined beneath a regular hexagon. The box uses 4 right triangles made of foam in its 4 corners. Find the measure of angle 1 in each foam triangle. So I want to find the measure of these angles, and they're all congruent. Well, let's start by talking about, well, what kind of shape we have. And it looks like I've got a hexagon. So if I have this hexagon, sum of the interior angles of a hexagon, 720. We take 6 minus 2 times 180. That's 4 times 180. So if it's a hexagon, I get 720 total degrees. Since it's telling me it's a regular hexagon, I know all the sides are congruent, and I know all these angles are congruent. And my picture might not look like it, but it told me they're a regular hexagon. All the sides are congruent, all the angles are congruent. So if I want to find the measure of one of these angles, I'm just going to take 720 and divide it by 6, and I'm going to get 120 degrees. So I know that each of these angles is 120 degrees. Well, now, angle 1 is supplementary with that 120 degree angle. Supplementary forms a straight, it's actually a linear pair, 180 degrees. So I'm going to take 180 minus 120, 60 degrees. So the measure of angle 1 equals 60 degrees in each of those triangles.